Hello and welcome to yet another YouTube Live here at Tuterac. Now we have been doing a lot of YouTube Lives which are deeply touching a certain technology. But today we are going to deal with something which is going to be slightly different. In today's modern world, whenever we actually create a very major service, think of something like YouTube itself or any other platform like Udemy or Coursera or Scalar or whatsoever, even if you consider our own platform, Tuterac. No matter what platform you're using, there is a lot of software engineering that is happening behind the scenes. Now, whenever this software engineering happens, we need to know or we need to understand that this software is actually going to run somewhere, right? So this software runs where? Well, if we look into today's world of how software engineering takes place, usually softwares would be a part of a server-based system or a serverless system. Mostly all the front-end systems are running on a server-based system. But when we talk about back-end technologies, they can either be running on a server or they might be running without a server. They can connect with databases, they can connect with other back-end technologies, they can have multiple connections from front-end and so on and on and on. So what I want to say is there can be multiple connections that can happen inside a certain technology. For example, if we try to talk about a very major technology giant like Google. So Google has Gmail, YouTube, Google Drive, Google Docs, Google Sheets, Google Maps, and many other Google products. But they all seem to work seamlessly with each other. So do you think that the seamless integration of all of these technologies happen with just one single code base? Of course not. So the way it would primarily work is that every single technology is going to have its own code base and then they're integrated with each other in some manner or the other. So when we talk about this integration, there needs to be a very strong amount of communication between one service and the other. No matter how small or how big your software is, there will always be situations when you want to communicate between two services in one way or the other. This communication is crucial so that your software remains maintainable and scalable as well. There was or used to be a concept of something called as monolith architectures, in which we would try to make one big chunk of code which is going to do every single thing. In this particular piece of system design, we didn't really have to bother about integrating multiple components together because all of the things were a part of a same single organism or a same single software or project. Think of it like a very large cell. Now, when I say cell, I'm talking about the biological cell. So if we talk in the biological terms, then think of it as a very large cell, which is just one single unit of functioning body. Whereas when we break down our functionalities into smaller units, and then we try to segregate them into its own unit and its own software, we get something like a multicellular organism, like us human beings. So it is a very crucial concept that is used in the software industry, especially and very much focusing on the idea and fact of breaking it down into multiple smaller technologies and components. With that way, the components that require more resources, it is very easy to utilize and allocate them those resources that they need. For example, let's say you have two softwares which are together making up a bigger software, software A and software B, which is, let's say, creating the software as 1, 2, 3. Okay, so software A, let's say, requires more resources than software B. So in that case, you can allocate more resources to software A or scale software A only in order to scale your entire application. This way, you will save a lot on costs because you don't really have to scale software B in this case, right? But sometimes there will be situations when, because the system is distributed, you might need to upgrade every single small component which are similar to each other, and therefore the costs may increase. So it has its own plus and its own minus. Well, now that we have spoken a lot about distributed computing, and then we have also spoken about how big softwares and small softwares can work together, whether you take one big chunk of piece of code or whether you take small pieces of code and clutter them together. Whenever we have to deal with at least the second one or even the first one, we always need to make sure that our systems are communicating with other systems as and when required. Let me give you another small, very technological example. And this is also something that I have worked with. Let me try to put this straight like this. Let's say that you are trying to create a system in which two people can chat with each other. Okay? Let's say you're trying to create a system in which two people can chat with each other. Or let's say, if I have to make it even more relevant, let's say you are creating a social media application. And in the social medium, let's say people can put pictures and you can add comments on their pictures. Let's say that I uploaded a picture, and let's say my friend Teja, he tried to add a comment on my picture. Now, as usual, I'm not really a very social media person. So I decide to, or I miss this comment that my friend has put. But the way the social media has been programmed, that in case if I miss, or in case if any certain activity happens on my picture, I will be notified with the help of an email. Okay, so I get to see a notification coming to my email address. So, did you notice what exactly happened over here? There is one system which is actually taking care of social media related operations, and one another software which is taking care of sending the notifications. So, let's say that in the social media company, there are multiple other services that are also trying to send notifications. So this notification service or this notification software is going to become a central point of contact for all the softwares that are present in a certain company in order to send notifications to any certain person or any certain user, right? So this is the idea where distributed computing is coming into picture. So just like the social medium application, there can be many other different types of applications present inside the same company that want to send notifications to their end users. So that is what we are trying to talk about. And in order to send notification to any of the user, we need to communicate with the notification service. But how that communication is done? It is done with the help of APIs. There are multiple ways to actually do this communication. There are asynchronous ways, there are queue-based, event-based, and also API-based. So I will not be going into the more complicated methods of communicating across different systems. I would mostly be trying to deal with the communication that happens on the ideas of API. So let's say that we have two systems, system A and system B, and then they want to communicate with each other. They can actually communicate with each other in terms of or in respect of APIs. It is also very interesting to know that even though both of these services or all the services written within our software might be written in even different programming languages, but they will still be able to communicate with each other. It is like English of the computer world, because every single piece of software or mostly all the frameworks are able to recognize and understand this mode of communication. When this mode of communication happens, especially in the API world, we have different types of APIs that we can create. We can create REST-based, SOAP-based, GraphQL-based, etc. According to a lot of software industry standards right now, the most popular is REST-based APIs. So in today's video, we will try to understand how we can make use of REST-based APIs in order to communicate within two different services. One way that we can do this is by actually creating one service at our own end and then communicating with any other service which might be hosted somewhere else. Or we can communicate or we can establish both the services onto our own system and let them communicate with each other. So I think I'm going to choose the second path, and then we will be writing some code. So in today's video, what I'm going to do is I will create a Node.js based system and a Python based system. So one Node.js based server and a Python based server where I will see or I will try to actually send requests from a Node.js server to a Python server and send response from the Python server to Node.js server and ultimately getting it back to the user. So that's my idea. So let us go ahead and see how we will be able to implement it. So coming to my screen, for in case if you're also trying to code along with me, you will need to have Node.js and Python installed on your machine, and you would also be required to have a little bit of knowledge around Node.js and Flask. Let us go ahead and see how we will be doing it. So I will be opening my code editor. In this case, I'm opening Visual Studio Code, and let me close it. It's not needed. So let me just open our Node.js project. So I think I might already have a Node.js project. Okay, I don't. That's totally fine. Let me just create one in that case. So I'll open my terminal. I'll write cda self tutorac. Okay, let me see. There is nothing over here. So you can see that there is something called a tutorac Flask app. So our Python application is kind of present over there. I'll still walk you through the entire piece of code so that you can understand how it's going to work. So let me just create a tutorac node app and install the relevant dependencies. So I will write I'll write mkdir tutorac node-app cd tutorac cd tutorac node app, and then I will write npm space init space -y. This will initialize my tutorac application, which is on Node.js, and then I will write npm install npm install. I want to write express. Okay, so now I've written express and it's absolutely installed. Great. Let me just go ahead and start my start my Node application. So let me just go to that folder. So inside tutorack, there has to be tutorack Node app. I'll open it. Great. So let me just open and create a very basic file, app.js. Over here, I will write const express equals require. Oops, not this, require express. And then I'll write const app equals express. Okay, then let me just write app.listen 7878 and a simple function like this, console.log node app is running. Great. Let's go ahead and start this. So I'll write node app.js, and you can see that it says node app is running. Great. Let's open side by side our Python project. So I'll click on new window, and then I will try to open my Python project, and here it is. So it is a Flask project. In case if you're new to Flask, Flask is basically a very lightweight library written in Python for backend development. So yep, this is what we have. So for doing this, what we need is we need to have Python installed on your computer. And then in this particular case, I've also tried to create a virtual environment for my Python. And after creating my virtual environment, I have installed one library only, which is Flask. So I have installed Flask onto my computer, onto this particular system. I've installed Flask, and then I've written some code. So over here, you can see that I'm importing Flask, making app equals Flask underscore underscore name underscore underscore, and then I'm just writing functions and I'm creating my routes. Okay, great. So let's say we want to send information from Python to Node.js or Node.js to Python. The ball is in our court. So let's say I decide to send information from Python to Node.js, and then the response will come from Node to Python and then from Python to us. Okay. Now, the thing is, what should we do? Okay, so we can do something like this. Let's say that we send we send two numbers. We send two numbers, and after we send these two numbers to the Python backend, and after sending these two numbers, we will try to identify the square of each of these numbers. And after identifying the square, I will try to ask my Node.js server that which particular number is let's say anything. I mean, it can be like which square is lesser, something like that. Yeah, we can do that actually, right? Or if I have to change the ideas, let's say if we take any two numbers, firstly we'll try to do a square of it in our Python project, and after doing the square, I will try to return it from Python. But I want to make use of Node.js as well. So what I can do is I will try to add these two numbers and subtract these two numbers in Node.js and send the information. So square of number one, square of number two, add or like sum of both numbers and difference of both numbers. That is what I'm going to do. So in which square of both the numbers is going to come from Python and the sum and difference is going to come from Node.js. So it's a very, very trivial, very trivial act. Technically, we don't do something like this in actual software development. We try to reduce the load on other servers as much as we can. But just for demonstration purpose, I want to show this to you. Okay, so let us go ahead and see how we will be able to do this. For now, I will comment out every single thing that is written over here. And I will write def, or I can just write @app.route / numbers. Okay, and here I will write def numbers. Okay, so let's say we want to take two numbers, right? Number one and number two. So we will write num1 equals request dot args dot get num1. Similarly, num2 is going to come from request dot args dot get. This is basically using query parameter to get the information. I also need to make sure that I convert them to float so that they are perceived properly. Float. Okay, and then I will write squares. So let's say sq1 is equals to num1 multiplied by num1, and SQ2 num2 multiplied by num2. Okay, so this is how we have the squares of both the numbers. Now send info to node and get sum and difference. Right? This is what we want. Lastly, I'll write JSONify. Inside it, let's say num1 SQ is equals to SQ1. And here I'll write num2 SQ as like square of number 2, SQ2. And then I have sum. For now, I'll just write 0 because we don't have it yet. And difference as, let's say 0 again. Okay, followed by 200. Okay, so this is a very basic piece of code that we have written. Okay, let's try to see if this is working fine only from Python's perspective. So right now we have not done any Node.js based information over here. Let's run it. So I will write flask -m -m app. No, I think it should be -app and then run. Yep, so it's running on localhost 5000. Okay, let's go ahead and check if it's working fine. Over here, I will remove it and I will write numbers. I think that's what I wrote numbers. So over here in query parameter, I will write num1 as let's say 15 and num2, let's say -25. Click on send. We have something happening, but we see that it's kind of stuck somewhere. So we'll have to understand what really happened. Or we actually did get a response. That's fine, but I think it took quite a lot amount of time, which is like 8 seconds. That's not nice. Let's click on send again. And yep, now it's 5 ms. That's great. So because our servers might be running on the debug mode, which is why sometimes at the very initial stage, it can take some amount of extra time. But as you can see, as soon as we make our next request, it is under 5 ms, which is a very good performance for any API. But technically, what are we even doing in this API? It's just basic arithmetic calculations. Okay, so we can see num1 SQ and num2 SQ are coming absolutely fine. I think there is something wrong with my code because I'm getting the same values. I think I should write SQ2 over here, restart my application. And now if I need to click on send, yep, now it's actually performing better. Let's say if I write -35, I get 1225 and so on. That's great. So our Python application is working exactly the way we expected it to be. Now let's go ahead and write some code inside our Node.js application so that we can send the sum and the difference of two numbers. Okay, so coming back to my Node.js application, here I will create a new route. I will write app.get slash sum difference. I'll write req, res. And over here, I will write let num1 is equals to, or I can just make it like this, num1 comma num2 is equals to req.query. Okay, and then I will write return res.status 200.send over here sum equals, nope, sum is equals to num1 plus num2 and difference as num1 minus num2. Okay, so that's how we can do it. But I just want to remind you that we need to convert num1 and num2 into actual numbers. So right, num1 is equals to number num1, and similarly num2 is equals to number num2. Okay, nice. So this is how we can actually get our information from Node.js based server. Let's try to hit it separately. So now it's running. I'll go back to my Thunder client. Let's say I'm currently running it on 7878, right? 7878. Okay, over here, I'll remove it. And then here I will write, let's say something like, I think I had some difference written over here. So I'll copy it, copy, paste it over here, remove it, go to query. We'll write num1 as let's say 15, num2 as let's say -25. Click on send. Let's see what we get. Still kind of processing. I think it's something wrong with Thunder client because usually it wouldn't take this much amount of time, but let's say in case if we get an error. So I'm still waiting for the processing to finish, and yep, we got it. So it says sum and difference. So sum is -10, which is correct, and difference is 40, which is correct. So now we have a situation where our Node.js server and our Python servers are actually working absolutely fine individually, but right now there is no linking between them. So we want to make sure that our Python server is actually able to make a request to our Node.js based server, get the additional information from Node.js based server, and send a finalized response to the end user. So let us go ahead and see how we can do that. I'll come back to my Python code over, no, this is my Node.js code. Yeah, I'll come back to my Python code, and over here, I will write some more code. So I need to make sure that I use a library called as requests. So let me just install it. So pip install requests. So downloading requests. So with the help of this request library, we will be able to make requests to a different location. So in this case, we want to make a request from our Python system to our Node.js based system, which is why we need to make use of the request library. So let's go ahead and see how we can make use of this. So I will write over here, import, or let's say from requests, or I can just write import requests as say HTTP. Okay. Now here I will write, we need to send the information to Node.js, right? I'll write requests or response is equals to requests dot send, or let's say I kind of need to see the documentation of how this works. So let me just open a browser, Edge, and as soon as I come over here, okay, as soon as I come over here, I will just write requests in Python. Okay, so we should be able to see this particular page, which is the official documentation. Okay, so now we need to make sure that we are able to send a request. In order to send a request, we need to see how this can be made. So I just want to go ahead and see the documentation over here. So yep, let's go to the documentation over here. You can see it says request.get, okay, and then it's followed by a URL and then some other information. Okay, let's try to add that accordingly. So I will write over here, this is our Node.js, this is our Python. Okay, so I'll write http.get. So the URL on which our Node.js server is acting as on localhost 7878 slash some underscore, see what I wrote it, I keep forgetting, sorry about that. It should be some underscore difference. I'll write some underscore difference. Okay, this is my URL followed by some other parameters. I'll write in parameters, I need to pass my query string. So I'll see how we can pass the query string. Let me see, passing parameters in URL, this is what we want. Okay, so this is how we can pass the query parameters. So let us actually pass our query parameters. So we will come back to this place and we will write params equals num1 as num1 and num2 as num. So I need to pass a Python dictionary over here. Okay, so this is what I wrote. And then I actually want to get the information. So let's see, there is, I'm pretty sure it has to be written over here. So if I go back, I need to read the data. Okay, I need to read the response body. So I want JSON response content. So I will go over here and I will see how this can be done. So r.json is actually going to give us the information. Okay, so let's go ahead and see how we can do this. So I'll come back over here and then I will write response.json. Okay, response.json. So it is going to give me something. So let me just print it for now. And let's see how this works. So I'll restart my server. Restarted my server. I'll go to this place and click on send. We see an error. Let's see what this error is. Okay, exception on /numbers. Okay, we'll have to check why this exception is coming. Okay, because our application is not running. Sorry about that. So let's go ahead and click on send again. gives a 500. Let me stop it, start it, click on send again. Still doesn't work. That means there is something wrong with the way our application is written or working. Okay, let's see what this problem is. So it says error, exception on numbers. Okay, let us see what this exception is. At the same time, I'd like to see if this particular thing is getting triggered. So for doing that, I will go to run, I'll click on start debugging, Node.js, and I will put my debugger over here. So if I just put a send over here, send call, it absolutely works fine. Okay, nice. So I'll go to my Python server and click on the send request function to see if our request is actually going through. So if I click on send, it does not send the request in the first place. Okay, so we'll have to know what is actually going wrong. So if we follow this particular thing, then we need to understand what might actually be going wrong. So let's see what can be going wrong. It says, okay, fine, there's data, that's great. Params as payload, that is also fine. So I think in my opinion, most things that we are doing is correct, but let me still see. I'll write HTTP maybe over here like this. And let's try to run it again. Click on send, and yep, the request is back. All right, so now you can see that our Python system made a request to our Node.js based system, which is why the breakpoint over here is stopping. So in case if I let it pass, you will see that this is our response.json. So we can see the sum as well as difference. That is great. So we'll take out the sum and difference from this place and we will try to send it over here. So I'll write sum is equals to, or I will write response data, response.json. And then here I will write sum equals response data, sum, and difference equals response data, difference. Okay, and then here I will just pass sum, and here I'll just pass difference. Okay, I'll go back to my Node.js system, remove the debugging point, and click on send. Oh, I need to restart my Python server. So restarted it, click on send, and now we see difference and sum also coming up on the screen. Okay, great. So let's change the numbers. So 56 and let's say 35, click on send, and yep, it's working absolutely fine. So here we were successfully able to see that our Python system and Node.js systems are actually integrated with each other. So our Python system is sending some information to our Node.js system. Our Node.js system is doing some extra work and is sending the information back to Python. And then Python is sending the overall collective response to the end user. So this is one way of how multiple systems can actually integrate and interact with each other, mostly with the help of APIs. In this particular video, I tried to show you that how REST APIs can be used in order to integrate multiple different systems with each other. There are, like I said, multiple different ways that this can be done, but REST API is one of the most standard ways to get this done. So this was pretty much it from my side in this video. We actually come live here every day and we try to cover an interesting topic every single day. In case if you like this video, it would be great if you can hit the like button as well as subscribe button to stay more tuned for videos like this. Let me see in case if we have any questions in the comment section, and we actually don't. Well, that's fine. In case if at any point of time you have any questions for us, please feel free to write that down in the comment section below and we will try to get to that question as soon as we can. Until then, I'll take my leave and I'll see you in the next one. Until then, stay connected with us at TutorRack.